Okay, so thanks for your inquiry, and many of you asked how this system works, so I'll just give you a brief explanation. It's pretty intricate, but I'll give you a pretty good rundown. What you're looking at is a 10.4-inch touchscreen. It's manufactured by a company called Crestron, which is a very high-end automation system that uses their proprietary processor. They make 27 different touchscreens to choose from, anywhere from 3-inch diagonal all the way up to 27-inch diagonal in hardwired devices or wireless devices. You can also use iPads or iPhones as controllers. So when you first take these out of the box, you program every single button that you're going to want on these touchscreens and how many different page flips you're going to need to get to the buttons that you want to. The unit powers up using a 4-conductor bus coming from the processor, and so therefore every single touchscreen is a unique ID being sent back to the processor. So every button press is what we call a join number, so you assign a join number to every button on the touch panel. The touch panel can handle as many as 5,000 join buttons, and we can have up to 256 IDs or addresses coming into the processor, which means up to 256 touchscreens. Then we have outputs coming from the processor. The outputs are triggering relay boards, which then in turn trigger tortoise motors, LED signaling, whatever you like. We also have input cards, and we have 96 blocks of occupancy on this layout, and those 96 blocks are actually coming into the processor as inputs. So when the processor sees that a particular section of track is occupied, in programming we can do whatever we want to do with that input. For instance, drive outputs, whether it be signaling, LED indicators on the touch panel, and so forth. So this is just one of the pages on the touchscreen, and you'll see that this is a very simple ladder design, and where you see the green lights show which way those tortoise motors, double crossovers, turnouts are set for right now. The clear route indicator shows that there's a green light, so that means that main line 1 and main line 2 are in fact satisfied for straight routing. But if I was on main line 2 here and I wanted to swing up into one of the sidings here, I would select my train location. So I would select that I'm here and I want to move up into this siding, and as soon as I press that, the green LEDs will line everything up automatically to get you into that siding. If I wanted to go from this siding here over to main line 2, it will automatically line everything up through the double crossovers and line everything up. So it's a very simple 2-button step to be able to get from where you're at to where you want to go. Main line 1 over to siding number 3, and it'll automatically line everything up. If somebody else wants to just come through the main lines, all they have to do is press a clear route, and as soon as they press a clear route, it will automatically line up the green lines and straighten out all the turnouts for mainline running. Now this is just one page showing one specific location on the layout. So on the main wall, where we have 4 main lines coming through with all these double crossovers, crossing over its own line and then also crossing over onto other lines, this mess basically created 6 reverse loops on the layout. So we're using some reverse loops or auto reversers to take care of the logic on that, but you'll see that the green lights are all for straight running right now. But if I wanted to cross over through this crossover here, all I have to do is press crossover 1 diverge, and now you'll see that the green light is through the diverged route. Now if I took a train, I'm going to put this back on straight, and if I took a train started it up, and now I'm going to back up into that crossover, you'll see that there's a flashing yellow light. The flashing yellow light shows you that that crossover is now occupied with something. Now that it's occupied with something, you cannot accidentally flip the crossover whatsoever, because there is a piece of rolling stock on that crossover. And as soon as I was to back off of that crossover, you'll see the yellow light go away. And now the train is off the double crossover, and as soon as it's off the double crossover, it allows me to flip that tortoise motor. So this just makes sure that you cannot turn or throw a turnout under a locomotive or any piece of rolling stock. Every piece of rolling stock has resistor wheel sets on the front and the back axles. On the roundhouse page, we didn't want each individual track on the roundhouse to be powered up all the time, being that this is a DCC layout. We'd have a lot of sound coming out of all these different locomotives. So in the roundhouse area, I do have a roundhouse power page, and there's roughly 15 tracks around the roundhouse. I'll show you pictures of that later. But if I wanted to turn on power of a specific track to send a locomotive out, say for instance track 3 in the roundhouse, I can just simply press 03 on, and it automatically turned on the power just for track 3 in the roundhouse. Or if I wanted to turn on all the tracks in the roundhouse, I can simply press all on, and by pressing all on, I now turned on all 14 tracks in the roundhouse. Or if I wanted to turn them off, I can just hit an all off, and it will turn off all the power on the roundhouse tracks. There's a couple of other different ways to which we do routing. Again, the first way is if I wanted to say I'm here and I want to go there, and it'll automatically route the switches to that particular area, and I can clear the routes anytime I want. I have other areas where I just have individual switches, where if I just wanted to throw a single switch, I can just throw single individual switches if I wanted to. Now remember, while I'm doing this, you'll notice that the feedback is switching based on the direction to which the turnout is sent at that time, and all of this feedback is also being sent to the 5 other touch screens in the fascias around the layout. So if somebody else is in another area, they will get the same feedback that somebody else is doing in another location. In the industrial area, it's a very simple one single turnout, and you'll see that it's lined up for a straight line right now. But if I'm here and I want to go there, it'll automatically flip that switch. Or I can clear it and it will straight line it again. In the setup yard, these are individual switches for the ladder coming out of the setup yard, and also then one switch that goes out onto the main line. So I can flip each individual switch separately if I wanted to, or if I wanted to just come out onto, say, track number 5 in the setup yard, I can press track 5 and it will automatically put whatever switches are necessary in line to come out onto track 5. That will not open up the switch going out onto the main line, because you may just want to do some switching in that area. But if you did want to go out onto the main line from track 5, you would simply take track 5, press and hold it for 4 seconds, and as soon as it blinks, you release, and not only will it line up the ladder, but it will also open up the switch to get out onto the main line. And you simply press track 5 again, and it will close off the main line switch, ready to go for main line running again. Then we also have test pages. So we have an occupy test, and these are the 72 blocks of occupancy plus another 8 here, plus more here. So it's a total of 96 blocks of occupation and track detection. And so anything that's green right now shows that there's definitely something on the layout within that block that's causing the track to be occupied. And so we're taking all of these indicators, and we're bringing them back into the processor. So if you are in a occupied location and you're within a switch, it will not allow you to throw the switch. Or if these blocks pertain to signals, depending on the different algorithms that are required for which blocks need to be occupied to which LEDs need to fire on the signals, that's what the processor does. This is also a service page if I want to run around the layout and just test each individual tortoise motor for each individual switch instead of relying on routing of multiple switches. If I need to test a throw rod or anything like that, I can go into this service page and simply throw one tortoise motor. Classification yard, we have three leads in the classification yard and a separate caboose lead, and we have the options of taking any one of those 3 tracks of classification yards or the caboose lead and send them out on the mainline 2 or to mainline 1 or the switch lead, and then there's also an arrival departure. The green indicator shows that there's really only one of these buttons of the 15 that are up here that can be satisfied at any given time. So if I was in the arrival departure and I wanted to swing out on the mainline 1, all I have to do is press arrival departure on the mainline 1, and it automatically lined up the arrival departure out onto mainline 1. If I was in the switch lead and I wanted to go to classification yard number 1, it will automatically swing over to classification yard number 1. Now, being that that one's satisfied, this one can't be satisfied anymore because it obviously has some turnouts that are affiliated with each other. Once you decide that you want to get out on, say, classification yard number 2 lead out on the mainline 2, and you press that, you would simply run your train out onto classification yard 2 out onto mainline 2, and once you are out of that area, you would simply clear the route, and once you clear the route, it will automatically bring all of your switches back to mainline running, so there's no derailing on the main lines whatsoever. In the Industrial Peninsula, we can do line art, and the line art shows individual red and green indicators showing which way each individual tortoise motor is thrown. And if you see a flashing yellow light here, that shows you that that particular runaround turnout is occupied. There's a train sitting on top of that switch right now. So if I was to flip that, it will not allow you to flip that switch because there's a piece of rolling stock on that turnout right now. But these are all set up as individual switches. It just makes it a little more challenging for somebody in an operating session. Alright, so I'm going to attempt to shoot video simultaneously while I'm running trains. And you'll see the signals here that are green, and as soon as that train hits that signal, it'll go red, like so. I'm going to move that train around a little quicker, because as that train goes around to the second block, you'll see that that red signal will go green, or I'm sorry, amber. And the second block is coming up. Now it went amber, and then the next block will be green, and there's our green light. Here's another demonstration in another area, and again, as soon as it hits this area, it will go red, like so. Now what I'm going to do is I'm going to back this train up. And it's back to green. If I go to this touch panel here, and I take that west crossover and I flip the crossover. Now that I flip the west crossover, you'll see that the greens are on the bottom and not the top. And that's because this train is going to cross over. And as soon as the train crosses over, you'll see that both of them go red because the crossover is now occupied. And as soon as they get past this siding here, you'll see that the one side is green. Now the reason why the right side is green is because if I had a train on this track right here and I'm crossing over, he's getting a green light. If I was a train right here and I'm crossing over, I have a yellow light because that train is one block in front right now. If that train was to get out further, that amber light on the left side here would go green. But if I flip the switch back over to straight line running, you'll see what happens to the LED indicators automatically. And now this track, because the switch, the double crossover, is set up for straight line running, this switch, or this driver now, will now get the amber light because that train is one block ahead. And this person would now be getting the green light because he's got to clear all the way through. As I continue moving that train out of the way, as soon as it goes over the bridge and goes into the next block, you'll see that that amber will go green. And there we go. And that just means that that train in front of him is at least 2 blocks ahead. Alright, well, I'm back. So we're now going through the unfinished area. But the signaling's all work. There's the roundhouse. Not completed yet, but all the track work is done. All the track work is all hand laid. I'm going to stop the train here and show you the double crossovers and what the mess was as far as why so many reverse loops. So by flipping 2 switches here now, this is on the inner track, and you'll see that as it comes through here, it's going through this double crossover, which is crossing over its own track, and then again crossing over back on to another track. That right there caused 6 reverse loops on the layout. And while doing all of this, all of the signals are doing what they're supposed to be doing. That'll go green. There they are. So as I come back through them, we'll get a red light on the bottom. And now that we're out 1 block, we have an amber on the crossover. As soon as we get the second block out, that'll go back to green. There it is. All these buildings were cut with a laser cutter. I designed them in Corel Draw and then cut them using 16th inch and 1/8 inch acrylic. Cut all the windows out, and I'll show you some areas of windows and windows mullions also. These window mullions were also all cut out using the laser cutter, and the brickwork detail is all etched using a laser cutter also. All these window mullions were done on a laser cutter. Glass block windows, I used the clear acrylic and then etched them with the laser cutter. Here's a photo of a cribbing wall, and these were all cut using basswood on a laser cutter, and the retaining wall underneath is acrylic, weathered, again done on laser. Wire spool loads, wood decking, and then I have sheets of shingles. So this is a HO scale shingled roof. They come in 5.5 inch by 8 inch sheets, and you simply pull them off and you glue each course down, starting with the bottom row and working your way up to the top of the roof. But each row is a single sheet, and you just glue them across. The original layout was approximately 42 inches off the floor. So this was the original setup yard of the first layout. This is now the third design in 3 years. So I started this one 14 months ago. I took the layout after I laid all the track, and I raised it 10.5 inches and left the setup yard at 40. And so now that track goes all the way under the layout and comes back up onto the main line about halfway around the room. So this is an area that's not even started yet. Again, the room is about 16 feet by 21 feet. This is about 14 months worth of work.